let's look at problem 3. The question is, a ball is thrown at a launch angle of 52 degrees above the horizontal from 1 meter above the ground with a velocity of 18 meters per second. So we have 18 meters per second at 52 degrees. Again, we don't want that, so I used SOHCAHTOA to convert it into its component parts. This was hypotenuse sine theta, this was hypotenuse cosine theta. Once we have that, get rid of that angle vector. You don't want it anymore. You can explain it as the ball was moving 11.1 in the horizontal and 14.2 in the vertical. They're asking how high did the ball go? What's its highest point? What's the highest barrier the ball can clear? They're starting from 1 meter up. This is what they want to know. So they want to know what this height is, and that's strictly when the velocity final is 0. Yeah. We're exploiting the fact that we know at the highest point the velocity final will be at 0. Only when you understand that can you solve these problems. Otherwise you drive yourself nuts. So let's use velocity final is equal to velocity initial squared plus 2a delta y. Delta y, we don't know just the change of y. Let's rearrange the equation. Velocity final squared minus velocity initial squared over 2a is equal to, don't forget what delta y is. It's y final minus y initial. How do we change that around? We have velocity final squared minus velocity initial squared plus velocity initial. How did we get that? We just merely move the velocity initial onto the other side. This is over 2a plus velocity initial. And we have an answer of 10.3 meters above the ground. That's how far the ball will clear. The second part of the equation says, how far will the ball go before being caught 1 meter above the ground? The nice thing about 1 meter above the ground is, it simplifies the formulas. We want to know if it's moving at a certain velocity, how far will it go? We know that velocity, yes. We know the distance, no. It's asking us how far will the ball go. Do we know the time? No, we don't. And again, how do I know I have to use this equation here? Because they're asking us how far the ball went in the x direction. We have no choice but to use this formula. There is no other formula up here that doesn't use acceleration, and there is no acceleration in the x direction. So we don't know distance, we don't know time. Let's find out what time is. Now, I went through the pains of finding out with the quadratic equation. Here, let me bring it up nice and close so you can see it. There's a quadratic equation. I don't know if you can see on this formula, but we have everything that you need to know. What is the position final? It's 1, right? It's at 1 meter above the ground. What's the initial? 1 meter above the ground. So again, it's hit 1 meter off the ground, it's caught 1 meter off the ground. So y final, y initial, you subtract the 2, you're going to land up with 0. Do you know the velocity initial? The velocity initial is, in the, once again, y direction, 14.2 meters per second. What is the time? We don't know. What is the acceleration? Negative 9.8. So I went through the pains of working everything out. Here we went into the quadratic equation. Here's the quadratic equation set up, and you come up with 2 answers. You come up with the answer of time being equal to 0 seconds, and indeed, if you look at the ball being hit at 0 seconds, it is at 1 meter. And then at some time later, it's at 1 meter again, and that time later is 2.9 seconds. So if you work this out, once again, for the plus or the minus, for the plus, I believe you get 0 seconds. When you subtract the square root of 14.2 squared, you land up with 2.9 seconds. So that's the quadratic equation method. I don't know if you want to use that. If you don't want to use that equation, there is the old school method. Again, we know if a ball is hit like this, we know at that point the velocity is 0 in the y direction. So we can exploit that and use this formula we've been using all along. The velocity final is 0. This is very, very convenient. We know the velocity initial, we know acceleration, we can calculate the time. But that only gives us time for half the motion. It does not tell us how long the ball was in the air for the full motion, so always multiply by 2. So for half the motion, for time is equal to 1/2 the motion, we get 1.45 seconds. If we double that, we get 2.9 seconds, which agrees with the quadratic equation. So we know it's been in the air for 2.9 seconds. Then we can throw it back into this equation. Distance is equal to velocity times time, which is equal to 11.1 meters per second times 2.9 seconds. And you land up, looks like it's like 33 meters or something like that. I'll let you calculate it. Or it says right here, 32.08 meters. So the answer is going to be 32.08 meters. All right?